In this example, we've been asked to combine all these resistors and to get a single equivalent resistor. So we're going to have to redraw this circuit multiple times, and I encourage you to do that when you get a problem like this. So let's start off, let's identify our nodes, because that'll help us see what's in parallel. And so you'll see that you don't have anything that starts and ends at the same node yet. But we do have this 2 ohm and this 4 ohm in series. They are not connected with a junction, they're connected with just a regular node. So a junction, a junction, a junction. So at junctions we can't have things in series, but this is not a junction. It only connects 2 elements. So these 2 things are in series. So we can start off by saying that RE is equal to R1 plus R2. In this case, we're going to get 2 plus 4 is equal to 6. So this right here will become a 6 ohm resistor. So I'm going to redraw this. I'm going to start working my math off to the right over here, since we're going to redraw it a couple times. Now it doesn't matter if you put the resistance here or up here. It doesn't affect the circuit. It's just a representation. So I'll put it off to the side and make it easier to see what we're going to do next. So we have our 6 ohm that we just found. We come over here and we have this 6 ohm. We have a 3 ohm. And as you get better at this, you'll realize you don't need to redraw the entire circuit each time, but we're going to do it since this is our first time doing one of these. 12 amps. So now we have nothing in series anymore, but hopefully you see that this 6 ohm and this 6 ohm are in parallel. They share the same top node and the same bottom node. Now this 3 ohm does not share the same bottom node, and this 3 ohm does not share the same top node. So we can't put either of these in there, but we can put these 2 6 ohms together. So 1 over R equivalent, we'll get 1 over 6 plus 1 over 6, and you'll find out quickly that anything that's the same number, if 4 is going to get half, it's going to be 3, but we'll go through the math. So 1 over RE will be 2 over 6. Don't leave it as a 1/3 here. Make sure you flip it back over, so RE will be 3, or 6 over 2. So these 2 guys are going to combine to become a 3 ohm resistor. Don't be afraid to redraw the circuit. As you get more experience, you'll learn how much you need to redraw it. Alright, so now, here is that new 3 ohm. Here is this 3 ohm. Here is this 3 ohm. And 12 amps. Now, these are in series. This guy is not in series. He touches a junction here and a junction here. He's not in series with those. And then nothing's in parallel. Well, I guess the 12 amp and this are in parallel, but that doesn't help us combine resistors. So, in this case, we're going to get RE is equal to 3 plus 3. Hopefully you can do that in your head. 6 ohms. So this will become a 6 ohm resistor. So we'll redraw it again. 6 ohms. 3 ohms. I'm bringing this one down. Let me clean up my ohms there. And 12 amps. Make sure this looks like an ohms, not an amps up here. Alright. So now these are in parallel. They have the same top node and the same bottom node. Now we aren't going to include the 12 amps in there, it's not a resistor, but we can include those 2. So 1 over R equivalent, and you'll get used to some of these fractions for these textbooks. They like to use a lot of the same kind of numbers. So our common denominator here is a 6. For this one, we don't have to do anything. To make this a 6, we have to make this 2, so put a 2 on top. And we'll get a 3 over 6. Again, don't forget to flip it. RE is 6 over 3, which is going to be 2 ohms. And so we are left with the following circuit. A 2 ohm resistor, which is our final R equivalent, and 12 amps. Now if you don't like reusing RE, what you can do is you can say, oh, this is RE 1 are RE prime. So I can say this is prime, this is double prime, this is triple prime. Like you can do whatever you need to keep them separated. As long as you kind of separate your work, you should be fine. But this is our answer here, the 12 amps and the 2 ohms.